Today I'll be deriving or proving Lagrange's error bound. So it's a very straightforward proof. So without further ado, let's just write the Maclaurin series here. So f0 plus f prime of 0 times x plus f double prime of 0 x squared over 2 prime plus f3 prime 0 x cubed over 3 factorial plus dot dot dot. And let's say we only know the value of f0 and f prime of 0, and we're trying to approximate f of x. So we're trying to approximate f of x, but we only know the value of f of 0 and f prime of 0, so we only have this value. And then the rest is just error. And we're trying to find the maximum value this error can take up. All right? So before we actually, in order to compute this error, we have to take a derivative of f prime of x, f of x. So the derivative of f of x would be f prime of x. This just becomes 0 because it's a constant. And this, the x just goes away. So f prime of 0, 2 times 2 over 2 factorial is just, they just cancel out. So we get this. And derivative of this, that would be f3 prime of 0 x squared over 2 factorial plus dot dot dot. All right. Now let's take a second derivative. It'll all make sense later on why I'm taking a second derivative. And this just becomes a constant. This becomes 0. And we get f prime of 0. And this x just goes away. The 2's cancel out. When we take a derivative, just f prime of 0 times x. And here, there's f4 prime of 0 times x cubed over 3 factorial. So we know that this would just become I'm going to write shorthand fiv. This means the fourth derivative of 0. And this would be x squared over 2 prime. All right, nothing that hard yet. All right, so what do we know to error? We know error equals this. This is the error part. All of this is error. So error would equal f double prime of 0. This error, excuse me, this error will equal this. Over 3 factorial plus dot dot dot. All right? And I want you to notice something here. This thing right here looks similar to this. All right, so now let's consider this f double prime of x. So I want to multiply x squared on both sides, and let's see what we get. So f double prime of x multiplied by x squared equals f double prime of 0 x squared plus f triple prime of 0 x cubed plus fiv, or f4 of 0 x to the 4th over 2 factorial. All right? And basically what I'm doing is I'm going to make this look as similar as possible to the error so we can compare it. Furthermore, there's something in my throat, sorry. Furthermore, I want to divide this entire equation by, let me see here, 2 factorial. So we're going to divide this by 2 factorial. And everything else will become divided by 2 factorial. So 2 factorial times 2 factorial. All right. Hopefully these steps are intuitive. And I want you to notice something. That this f prime of x times x squared over 2 prime is greater than or equal to error. So we found our bound. And let me just expand this. So error would equal, and here we would have fiv f0 x4 over 4 prime, right? plus dot dot dot. Look, let's compare this term and that term. This term obviously equals this term, no matter what, all right? This term is going to be bigger than this term because it has a smaller denominator. So this term will be bigger than that term, and then this term will be bigger than this term because 2 factorial times 2 factorial is only 4. 4 factorial is about, let me think, whoops, 24, I think. So this term will be bigger than that term, and you can see that the next term, the fifth derivative term, will also be bigger than this term, all right? So we know that this thing is always bigger than the error. So we found our error bound. This is the error bound. And a more general formula for this. So we cut it out of f of 2, right? So error, or hold on. Okay, let's define some variables. Let n equal the last term. The last term, all right? Or hold on, how do I want to phrase this? Let me think. So this is our n, right? Okay, n last term of, I don't know how to phrase this. N equal highest derivative, all right? What I mean by highest derivative is, in our scenario, the highest derivative is 1 because we stopped at 1, right? And then we just removed everything. So n would equal the highest derivative. In this case, it would be 1. So a general formula is that here, f of n plus 1, the derivative of f to the n plus 1 of, oh, whoops, this is 0. This is 0, sorry. Wait, would it be 0? No, it would just be x. It would just be f of x multiplied by n, or x to the n plus 1. And this is only for a Maclaurin series. But most functions can be approximated with the Maclaurin series. So, and you could also, you know, by some simple thinking, apply this to other types of non-Maclaurin series. And n plus 1 factorial. All right, so let me write it better. It would be f n plus 1 to x times x n plus 1 over n plus 1 factorial will always be greater than the error. All right. So for our most recent case, so our highest derivative was 1, all right? And this we found was our error. This is our error. That means, and we see this 2 everywhere. And guess what? 2 equals n plus 1, right? Because our highest derivative is 1. So n would equal 1, and yeah. So, so 2 equals n plus 1. So we just substitute n plus 1 for 2. And we get this general formula. All right? And usually, the value of x in here usually takes on the maximum value of this f of n plus 1 here. All right? So this is the proof. This is the one of the more straightforward proofs. Okay. All right, and thank you.